Hey everybody, it's Miss Rogers. I'm doing a quick fraction review today on just reviewing adding and subtracting fractions in multiple cases. So I really want you to kind of go through and take notes if you feel like you need to and practice the examples that are in here before you practice or do the assignment for this week that's called FR1. Okay, and then on Wednesday, you'll also have fraction review 2 that will go with a practice section called FR2. All right, so I wrote the steps in here for you, and we're just going to go through just kind of reminder, just a refresher, because Mr. Turner said that some students were struggling with some of the point and slope equations that involve fractions. So I thought I'd make a quick video to show you some of the steps and just remind you how to add, subtract fractions. So the first thing is your denominators have to match. So that's like cutting a pizza into parts, and all of the sizes need to be the same size. So that's what you're doing here. So for example 1, and the first step is you're going to double check that the denominators match. That's the one on the bottom. Then just add and subtract the numerators just like normal. So you go straight across. 2 plus 4 because the denominators match. So that would be 6 for your numerator. Then the step says keep the denominators the same. So that just tells you you have 6 pieces that are all the same size cut into sevenths from a whole pizza. Okay? And then if your fraction needs to be reduced, you need to do that before you finalize your answer. Okay, so example 2, why don't you try it? I'll give you a couple seconds to come up with your answer. And then we can do this together. So 8 minus 5, your left to right, would be 3. And then the denominator matches and it stays the same. You do not add, subtract the denominator. That tells you how many pieces of a whole that the thing has been cut into. All right, so this one has a common factor. So 3 goes into 3 and 3 goes into 9. So we're going to divide the top by 3 and the bottom by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So we have reduced that fraction to 1/3. Okay, so that's how you add and subtract fractions when your denominators already match. Okay, so the next examples we're going to do revolve around what to do if your denominators do not match. So the first thing you have to do is find a common denominator. So you have to figure out what the denominators can both go into. So if I count by threes, so 3, 6, 9, 12, 15, etc. And then if I count by fours, 4, 8, 12. Oh, look, I found a number that's in the same list. So that tells me that 4 and 3 both go into 12. So that's one way to do it. And so if we want to make 4 turn into 12, we have to multiply 4 times 3 to make it turn into 12. So if I multiply the bottom by 3, I also have to multiply the top by 3. So that changes it to 3 twelfths. Then plus, now you have to figure out what do you multiply 3 by to make it 12. Well, that would be 4. So if I do it to the bottom, I have to do it to the top. So then 2 times 4 would be 8, and 3 times 4 is 12. Now the denominators match. So now you are allowed to add the numerators or subtract the numerators if that's what you have. So 8 plus 3 is 11, and the denominator stays the same. And this one cannot be reduced any further. Okay? All right, so for example 4, if you notice, 5 actually goes into 10. So we don't always have to change both denominators. We just change the one that needs to change to match the other. So in this case, you have to figure out, what do I multiply 5 by to make it turn into 10? Well, that would be 2. So if I do that on the bottom, I have to do it on the top so that I don't change the value of the fraction. So then 3 times 2 is 6, and 5 times 2 is 10, then minus 7/10. Well, if I do 6 minus 7, I get a negative 1, and then the denominator stays the same. So it's okay to have a negative fraction. That doesn't affect anything in this case. It's just the process that we're trying to work on, okay? All right, so go to the next. So adding and subtracting mixed numbers with like and unlike denominators, okay? So for the example 5, we have to go through and double check if there is a common denominator. If the denominators match, you don't have to do anything. If they don't match, you need to do the same process from the previous example. All right, so we look at 3 and 11. Well, if I count by threes, there's not a number that 3 also goes into that 11 goes into, except for 33. So I'm going to multiply this denominator by 3. If I do that to the denominator, I have to do it to the numerator. When you're changing your fraction to have a common denominator, you don't have to change the whole number. So nothing's going to change there. So this is just going to become 4 and then 27 over 33. Okay? And how did I know 33 would be the answer? So if you just count by 11, so 11, 22, 33, 33 is the first number in that list that 3 also goes into. So that's how I know. Okay, and then the next one, we have to multiply 3 by 11 to make it turn into 33. So the whole number stays. 1 times 11 is 11. 3 times 11 is 33. So now that the denominators match, you add and subtract the whole numbers and add and subtract the numerators. And then you can regroup if necessary, and I'll show you what that means in just a second. So 4 plus 1 is 5. 27 plus 11 is 38 over 33. So when I say regroup if needed, what that means is if you have to convert this back to a proper mixed number, your denominator is 33, your numerator is 38. That means you have more than a whole. So I'm going to subtract this. So 38, I'm writing with highlighter, sorry. So 38 over 33 is the same thing as 1 and 5/33. Okay, because 33 33 is 1, and then you have 5 left over to make up the 38. So 38 over 33 became 1 and 5/33, but we already had 5 wholes. So here we have to add our our whole number. So 5 plus 1 would be 6, and 5 over 33 is the final answer. Okay, so that's just what happens when you add fractions. If you end up with an improper, you have to fix it. But since we already had a whole number, you have to add the whole numbers together to get 6. And then the leftover is 5 out of 33. So your final answer is 6 and 5 over 33. All right, so the next example we have 2 and 8/9 minus 1 and 1/3. So again, in this case, if you notice, 3 goes into 9. So we need to make this denominator out of 9. Sorry, that's the wrong number. We need to make it out of 9, which means we have to multiply 3 times 3 to make 9. So if I do that in the denominator, you have to do it in the numerator too. So then that becomes 2 and 8/9 minus 1 and 3/9. Okay? So now we're just going to look. We're going to subtract our whole numbers and subtract our numerators. Okay, so 2 minus 1 is 1. 8 minus 3 is 5. And you keep your denominator. And that one doesn't require any regrouping. Okay, one other example that I didn't put in here is sometimes you have to borrow from your whole number, and that becomes a whole nother process. So if you get to that part, I don't think we've assigned any problems like that, but we'll definitely review that and go over it together. All right, so now we're going to add and subtract signed fractions. So what that means is you're going to think about your integer rules. Also, there's a typo here. Sorry, that's just a follow. So remember your integer rules. If you have like signs, you just add them, okay? And you keep the sign. But if you have unlike signs, you subtract them and you keep the sign of the bigger. So that's very important to keep in mind here. So don't forget, first you need a common denominator. So we're going to say what the 8 and 3 both go into. So if you count by 8s, you have 8, 16, 24. Oh, I found a number that 3 goes into. And the next would be here. So we have 8, 16, 24. So 8 goes into 24 and 3 goes into 24. So what do you multiply 8 by to make it 24? Well, that would be 3. If you multiply the denominator, you also have to multiply the numerator. So that would give you negative 9 over 24. Plus, now we multiply this fraction on top and bottom by 8. So that would give you 16 over 24. All right, so here's where the integer rule comes from. Since you have unlike signs, you subtract the numbers and keep the sign of the bigger, okay? So now there's a lot going on in this problem because you've got a common denominator and you have integer rules that you have to follow. So now you really can just rearrange this. This is the same thing as 16 minus 9. Then 9, you keep the positive sign. So negative 9 plus 16 will give you a positive 7 over 24. And that will be your final answer. Okay, so your integer rules work for fractions just like they do with whole numbers. You just have to remember them, okay? All right, so then example 8, when you subtract a negative, that actually becomes adding a positive. So those two signs become plus. So then you just have 3/4 plus 2/3. Okay, so 3/4 plus 2/3, we just have to get a common denominator here. So you're going to multiply that times 3 over 3 and times 4 over 4. Okay, so 3 times 3 is 9 over 12 plus 8 over 12 is 17 over 12. So this is where we have to look at making a improper fraction now because your numerator is bigger than your denominator. So 12 goes into 17 one time with 5 left over, and you keep the denominator. Because we know it's one time because 12/12 is one time, and then 5 is the leftover that made 17. So this is where the numerator of 5 comes from. Okay? All right, and that's it for this lesson. So now that we've kind of reviewed fractions, now it's time for you to practice. So you have a problem set called FR1 to complete, and you have 2 attempts to do it. So if you have any questions about it, please don't hesitate to ask or join the Zoom to ask questions as well. Okay? Or you can email. All right, guys, have a great day.